Okay, in this session, what we're going to do is talk about how to use SolidWorks to do your truss for the truss slab, where you're designing 3 different trusses. And the first thing we're going to do is when we go into SolidWorks and we say File, New, we're going to come up with a screen that looks like this. I'm going to get my screen to look like what some of yours may look like. If this is the first time you're in SolidWorks, you've got a part, an assembly, and a drawing template that we can leverage for creating that part, for example. And so I could click on this part template right here. Now, when I'm talking about templates in SolidWorks, we can have templates that have all the settings and preferences that we want to have saved inside of that template. So I'm going to go ahead and leverage one of mine. What you can do is just use the standard part template, and I'm going to show you what changes you need to do to make it just like what mine's going to be here. Now, what kind of stuff would we want to store in a template? Things like the units, the drawing convention, are we going ANSI, ISO, those various things, what kind of menus, just everything that we'd ever want to have in there. There's lots of stuff we can store in these templates. And so basically what we need to change in our template is I can go up here to this little gear right here that says options. You notice I have a menu that's opened up here and it's pinned, and this is going to have tools and options as well. So if I just click on either one of those, if I hit this options, this is going to pull up our main options that we need to change. And if you're using and you're leveraging the template that came with SolidWorks, pretty much the only thing that we're really going to change here in this course, because this isn't a full SolidWorks course at all, we just want to come in here and make sure that we're in ANSI drawing standard. Now mine says modified because when you click on this, you're probably going to be able to use the ANSI. And when you come down to units down here, you hit inch pounds, and I changed this to usually 3 decimal places right here on length. That's a real typical unit of length in the inch system we're going to have. It will put that as a modified ANSI, and that's okay. So we're going to accept those changes. That's the only thing I'm really doing in there. The other thing that I might want to do is come in here and just highlight these. I'm shifting all these and just coming in here and hiding these planes. Now, I still can see the planes if I hover over this. So I really don't need those because they'll actually conflict with some of the drawing lines and kind of be confusing to have too many lines in there. Let's talk about your screen. So you do have 3 different planes here. You have an origin that can show up in the center, and you have this little triad right here. Basically, we're going to want to draw on this XY plane right here, which corresponds to this front plane right here. So the other planes, that's a XZ, this is a YZ plane. So we're going to leverage the front plane here for our sketches. Now we've saved our units and did all this fun stuff, got everything kind of ready to go, and what we're going to do is go into sketch mode. I have my plane selected there, and oops, sorry about that, hit sketch, and it's saying what plane. If I want to, I can come in here and say that plane right there, and it's going to go normal to that. I can see that I'm in an XY plane. Anytime I move my mouse by holding the middle button around, I can move that triad, move my part around. I can always hit space bar, normal to, and it'll take me normal to that surface or that plane that we're drawing on. What kind of lines are we going to deal with? Well, I'm going to a line is a construction line. A center line is actually a center line is construction line. Line is going to be for geometry that we can extrude. I'm going to start with the center line, and I'm going to, if you notice, I hover over the origin. It puts a relationship to that center, and I can banjo a line out, and that's the center line. That's our construction line that we're creating. So I can come out here and do that right there. You notice when I banjoed it over, it did a horizontal line, and that line has a horizontal relationship. If I come up here to sketch dimension, I can come in here and tell this line to be 12 inches long. Okay, now our line is going to be 12 inches long, so I'm going to support this from right here to here, kind of like a supported beam. I'm going to put a load somewhere up here, and what I'm going to do is come in here and draw a line. I'm just going to make it coincidental to that piece, and we're going to put some dimensions on this as well. So I'm going to come in here from that point to here, and I'm going to say that is 3 inches. And the next thing I want to do is come in and just go ahead and finish all my other, well, I need one more dimension. I need to tell it where this is relative to this point. Oh, sorry about that. I didn't hit dimension. From there to there, and let's do that at 3 inches. So I have this point, this is where I'm going to put my load. So this is similar to what you guys are doing. I'm going to have a load point pushing down here, simply supported here at this node and at this node. What I'd like to do is go ahead and draw some more lines in here and represent that. I'm going to put a couple more lines in here. I'm going to come in here at this midpoint and come down to here, and then come over here to this midpoint. Now I'm going to go ahead and delete that line right there. And the reason I did that is I'm going to come in later and put a member there, but I want a member to be represented on all these construction lines here. And we're going to hook a bolt at each of these nodes connecting to the other member on the other side. So this is looking good. So we're going to introduce the next concept of offset entities. And if I come in here and select this entity, it's going to one side there. So it's coming off to this side. If I hit bidirectional, it goes off each side. And I can come in here and just select all the members I want to have that offset to. And all those are at 100,000. So that looks really, really good. Now then, at each of these points right here, what we're going to want to do is draw a circle with a hole in it so that we can make our mount to our bolts connecting each side of the truss. And the way I would do that is just go to here to, I'm still in the sketch mode, go to that circle. And I'm going to come in here and just go this big. And we're going to put a dimension on that. I could type the dimensions when I do the geometry, but I like putting the dimensions on here so I can see them. And that is 0.25. That's going to be the hole that the laser is going to cut for this. So we need another hole. And if you notice, I hover over that, that's concentric about that circle. I'm going to make this one half an inch in diameter here. There we go. So 0.5. Now then, I have both of my circles drawn. This is where I'm going to drill. Now we're going to trim stuff out later. What I'm going to do is talk about how can I copy these two lines around to each node. And what I'm going to do is come in here and just window. This is probably the easiest thing I can do. And you can go up to edit, copy, and paste. So you have the same commands that you have in Excel and Word. So I'm going to copy this. And I'm just going to go to each of these places and I can hit Control V and I can just hold that center and drag it, and it's now there. So we're going to repeat that at each point that I would like to see that. So at this point, we've put our holes where our nodes are going to be, and the next command we're going to want to do is I'm going to come down. Let's see, where do we want to do? Let's do it right here on this one. I'm going to come in here and I'm going to trim away the things I don't want to have. So this member, I'm going to have the material coming this way. It's going to go around the part, making the hole, and it's going to come down here to this member this way, and it's going to go up to this member. So we're going to use trim to trim the things we don't want to have. I like power trim, it's the easiest, and the way power trim works is you pick your first button and hold it down, you draw a line, you can barely see the line there, it goes over the things you don't want. Now if I made a mistake, you see that red dot, you can go back over it and it will actually come back up. So I can say, hey, I wanted those gone, I want this gone, I need those gone. Basically, you're going to go through there till you clean up everything that you don't want on this drawing. So now I am getting rid of those, and you can tell it's starting to look kind of like the material like I wanted. Now all I need to do is clean this one off, and this off as well. So now I have my material flowing here around, can go this way and this way. Yes, I see there's a difference in grays. That's going to self-heal itself when we go over here and trim all these other ones off. So let's go around and we'll trim all those off and we'll come back and see where we're at. We have all the holes at each node point done, and if you notice, I have a lighter gray out here with a darker gray inside. So that's letting us see that we have a continuous surface running on this place and another surface at this, so we could kind of see. I don't want to extrude these. I'm just going to want to come in here and extrude the lighter gray surface there. And the way to do that is we're going to go ahead and finish our sketch at this point. And that is my sketch. Now I can see those construction lines, and I recommend leaving those and don't trimming those off at these points in case you want to come in here and modify it and leverage those as construction lines. Being a construction line, it won't extrude and it won't come across as a DXF file when we save this as a DXF. So the next thing we want to do is if you click on sketch here and you hit file features, we can do extrude, and this is going to let us come in here and extrude this. Now, if I just hover over my part, it's letting me pick different areas. What I want to do is probably pick that section right there, and you notice it kind of went yellow, and I can see that the member's wanting to come out here. And if I would just scroll through this, I can make it as thick as I want. Now the question is, how thick do we want this? Well, right now we're using 3mm material. We're in an inch drawing, so I'm going to put the math, so I don't have any kind of rounding error. I'm going to say 3mm divided by 25.4, and that's going to get my units correct. Basically 118 thousandths with some change there. And I now have the thickness of my part showing up here. And so that's my frame that I need cut. What do we need to do to finish this frame? Now, what we're going to do is come in here and put material on here, and we want to edit material. And this is going to come up with kind of a short list of materials and categories. We're going to go to plastics, and we're going to leverage this acrylic medium high impact plastic. We're going to apply that, close it. You notice my part now kind of looks somewhat translucent on there. I can see through there somewhat, and that's going to represent the acrylic piece that we're going to have on our part. So if I do something like mass properties right here under evaluate, now again, if you don't have the tabs that I have and I use one and you need it, you can always right click up here and go to tabs, and you can turn those tabs on. So if evaluate wasn't there, you can use that. Evaluate is going to let us do things like measure, or if we wanted to see the mass properties, how much should this thing weigh? It now knows the material, and it can tell us how much pounds. We can convert that to grams really easy for this experiment. And so we now know how heavy this member is going to be. So at this point, I would recommend saying File, Save, and save your file as the file name that you're going to want. So maybe if this is Truss 1, put your group number and Truss 1 on there, for example. The next thing we want to do is come in here and do a FEA analysis of this part. Now, this is not an FEA course that we're going to analyze this frame. We're going to put the load on it and the conditions that we're going to put in the machine. And what kind of conditions are we looking at here? We're looking at putting a support here, a hinge type pin, and one over here. And then we're going to put the load on this member right here. And we're going to see, what does that look like strength-wise? Is it going to break here, here, or where is it going to tend to break? Now, again, we're not a FEA course, finite element analysis, but we're going to leverage some of the basic aspects of this and just kind of help you learn how to design. In the first lab, you guys did an excellent job of analyzing a couple of truss systems, doing some method of sections. And what we're wanting you to do in this one is to see the next leg of technology, which is FEA embedded in our CAD system, which is computer-aided design. Now again, a toolbar that we're going to use is going to be this simulation. Again, if it's not there, click in this area, turn that toolbar on. And what that's going to let us do is come in here and we're going to start a new study. Now, when I do a new study, it's going to add a new tab down here. I'm going to do a static study. So it's kind of hard to tell, but that is grayed out right over there, right next to study, and we're going to accept that. So this is a static study. We can do a lot of different cool studies within simulation. And the next thing we need to do, we've already applied material because we've done that right here. It shows our material, and that's going to come across now. Probably before we get to doing too much into this, we probably want to make sure that our units within this are going to be units that we're happy with in terms of the simulation. Now, simulation units typically won't be the same, or they could be different than the template we use to draw the part. So I would recommend going down here to simulation options and making sure that our default options here are in inch pounds. And I'm going to be happy with that. So we don't want to mix our units up. You don't want to go putting loads and all these kind of things on, just like we don't want to draw our part and then change units, because if you draw something at 1 inch and it was actually 1 millimeter and you think, I'll just change the units, it's still 1 millimeter. It'll just be on the scale of the inch system. So we got to do those settings initially. So we are in inch system, PSI, something that most American students are going to relate to a little bit more than the newtons and such that we're going to put on here. Let's see, we've got this. We want to talk about, so we did our study, did our material. We want to come in here and we're going to put a fixture on this. And the one you're going to want is a fixed geometry. Now, this is not the kind of geometry you're going to want to have where it's fixed and it's bending off there. We're going to want to have this hinge type that we can come in here and hinge this. And we're going to have a bolt that goes across this direction over here on this one and across over here on this, and that's where we're going to put our load. So we're going to let it hinge on that face right there, and we're going to come over here and pick this other face right there. So we can see the faces highlighted. If you pick the wrong one, just delete it right there. You can right click and delete it. And we now have both of those as a hinged fixture. And that's looking really good. So we've got those both selected. Now at this point, we're ready to come in and put our load on here. And we're going to go to load. We're going to put a force. And the force we're going to pick is, if I just move my mouse around, it's letting me see lots of options. I want it to be on that surface right there, that face. Now that's showing the force being applied in all directions out from that face. We do not want that. What we're going to do is, while I have that selected, now if you notice, I've got two faces over here it kept on my system. I just want the one that's purple right there. I don't want the ones that are down here purple. You should only have one face selected there. So make sure you only have this face that's related to that. And we're going to go in here and we're going to say we want to select a direction. At this point, I can open up this little menu here, and I am going to leverage this right plane so I can make the force go up or down parallel to that plane. And if I come over here and hit this, you can tell the arrows are going up here. What I'm going to do is hit reverse direction. Now they're going down. So on that face, that bottom half of that face there, we're going to be pushing downward. Again, we're going to have a pin that goes from here over to the other one, and we're going to be putting our load down there. And what I want to do is put 50 pounds on here for right now. Just see, how does our frame deal with that? So we now have a 50-pound load and our fixtures connected on this. The next thing that we do in the FEA is we're going to do a simple run on this. And when we do this, it is going to mesh the part into little nodes, and it's going to connect that in different techniques. It's going to have the ability to calculate each force from each node in essence. So let's go ahead and hit run study. And we're running our study on this. Now, some computers may be faster than mine. That's great. If I look at this, I can kind of see the orange frame in my initial frame, and I can go, oh boy, that looks hideous. It really has changed a lot. This is an exaggeration of, yes, this frame could bend and deflect much like this. And we're looking at a stress plot over here. And before we talk about the stress plot, I want to show you the mesh of this part that we did this calculation. So this shows the meshing of all these nodes, these little triangles basically, and it's doing all the calculations within that. Now we're going to be happy with the meshing technique on here because we kind of have an auto technique put on there, and it's going to do a fair job. If we were in a heavy FEA course, we would talk about the meshing techniques, the size of the nodes, how do we know when they're big enough or small enough, and how we can change our processing times. So we're looking at our stress plot now, and this looks really kind of questionable, like did this thing break or not? We really can't tell till we look at this main key over here. And we have some terms we need to add to our vocabulary. Von Mises stress. What is von Mises? In a short definition, it's combined stresses. So things like shear, bending, torsion stresses, we're combining those as one common stress. So we can sum the squares and square it and get that kind of result. We can relate that to the yield strength of the material, because when we pass the yield strength of this, we're going to assume this material is going to break, especially this acrylic, because it's very brittle. So it's not going to have a lot of deformation occurring after the yield strength of this. Once we get to the yield strength, it's going to be snap, crackle, pop for this thing pretty much. Looking at the yield strength, that is pulling up from the material we selected right here. And this is all in PSI. And if you notice, this little arrow is showing up right here. So what we're seeing is anything that is probably red up here, anything that's getting close to yellow, we're really getting close to what this material can handle. So if I start looking at stuff, odds are more than likely this thing is going to break. And this is not a good sign. We can see where the stresses are developing, and maybe we want to come in here and add some more material in this member or this member here. You look at things here, these members are really not doing much in terms of load on the stress on them. There's not a lot of stress in that. So if we wanted to make the frame lighter for some reason, we could come in here and decrease the material here. That's not going to make it hold anymore, but it's going to make the frame lighter and carry the same weight. So we can do a lot of playing around with this. Some other things I want to point out that'll help you on your design, because you guys are going to have to design your own frames and figure out what kind of standard truss system you want to use, what kind of members you're going to have, and how many of these nodes I'm going to put to keep my members going from one side to the next. And you need those because you can get out of plane bending if you don't have those, and it could cause your structure to fail. And the FEA would analyze that as well. So what we want to do is come in and talk about another tool that you might guys like. I like this Design Insight right here. And there's a neat little scroll bar for you. If I bring it all the way down here, this is going to show me the most loaded items. And if I slowly increase it, I can see where the highest stresses are going to be. And this is a little bit clearer for me. So I can really see the members and the sections and the areas that I need to improve on. Okay. Now then, that's one run of the part. Can I change my geometry and rerun this? Yes. Down here we have model, we have static. So let's go to the model. And what I'm going to do is add a member from this node down to this node. And probably the easiest way to do that is to just go to sketch, and I'm going to come off of this surface right here. And I'm going to go ahead and draw a center line from here down. And I'm going to do what I did before. We're going to offset that 100 thousandths on each side. That's looking good. I don't want to redraw these circles or arcs. I can use convert from entities. I can convert. I don't want to do that one. I was thinking I was going to get the face there. Sorry. I'm going to get this edge. That looks good. And I need to come down here and probably pick that edge and that edge. So I have the 4 edges, and now there are black lines there. You notice there's not a black line here where I didn't select. There is one there. So I can come in here now and do a power trim. You guys are real fans of that, and I like that. We trim that off. And those geometries will be associated to the geometry in the part. And you notice I accidentally cut my line there. So if I didn't want to do that, I can undo. That's going to come into place. I can come back in here and say I wanted to trim that off and those 2 off. And so we now have this member, and what I'm saying by associative, if I change the diameter of this circle, this would change in respect because I converted it from that edge. And so it's associated to it. So we now have this sketch ready to go. And I drew this intentionally on this face. When I drew my main extrusion, I drew it on the back side and extruded it upwards, okay, going up positive Z. So when I did this sketch, I'm going to have to extrude it negatively into the part. And what I want to talk about is I'm going to come in here and I've got this. I'm going to hit extrude. When I extrude this, you notice it's coming out the wrong direction. So I can flip the direction. I could accept this dimension right here, but if I ever come in here and change this thickness, I'd have to come in here and change it as well. So what I'm going to do is come in here on the back side of this part right here, and I'm going to, instead of saying blind, I'm going to say up to surface, and I'm going to do it to that surface right there, so that anytime I change the thickness of my part, that member would change exactly to match. And so I only have to change one number in that whole thing. Now these things are merged together, and it is now a new frame. So let's say I did some changes and I wanted to analyze these changes. I can go back to static, and all I have to do, because I didn't change any of my load conditions, they're all showing good, is just rerun the study. And now I can come in here and verify what's happening to my structure. And it still looks like it has some heavy distortion on here. One thing I noticed is I did a little probably a bit better on terms of my load, but that member adding it really didn't do that much for the overall performance of the structure. So I would need to do some more testing, figure out where I want to put things and how I can come in here and strengthen it. Maybe I need to make these members bigger in my next revision. And the way I drew it, I can go back in there real easy and change those in the sketch, and I can modify that out and come back in here and see this. Now, what kind of load do I want to see? Let's say that eventually I get it where the yield is not showing and the frame is a lot stronger. Well, you can come in here and put a bigger load on here. So I could edit this definition. What if I wanted to put 75 pounds on here? Now, some of you guys are going to have frames that can hold 100, 150 pounds per side, and that's going to be pretty impressive. So I changed that. It puts a little notice here that I need to change the results, so I'm going to rerun this. And if you notice, because I put a higher load on it, now things that are green are definitely going to break. This frame's getting weaker It's not so much the frame's weaker, it's just I'm putting a bigger load and it will break in those areas. If I wanted to see what it would look like with a 35-pound load, I could say, would this thing hold 35 pounds? We could go on down. That's the opposite direction we want to go and rerun this. And you're going to see the yield come up off of this. I wanted to show it. So there the yield is off this. So if it's red, it's probably, none of this is probably going to break at 35 pounds. So my frame will hold 35 pounds. But again, I said some of you guys are going to hold 100, 150 pounds, and we want to make our frames as light as we can and hold as much as we have. I've seen some people with some very light frames hold some high loads on there. So this is hopefully going to help you out to do some analysis using FEA and give you guys some cool ways you can design your frame and do on-the-fly calculations with it, just like we would do in industry, because we would do this, and then once we get it to where we want it to be, we can go out and manufacture it. And when we go to lab, we're going to take this frame then, and we're going to take a DXF of this file. We're going to cut it on a laser. We're going to cut a left and a right side. You're going to assemble them, and we're going to load it just like we talked about in the simulation. And then we'll compare your simulation with the real world results that we get. Now, how do I get this to DXF? Okay, here's I'm in the model mode here. And what I'm going to do is go to File, and first thing I'm going to need to do is probably save this. And I'm going to save this as on my desktop as just demo for right now. Yeah, I've probably got another demo out there because I save a lot of demos on there. And I saved my file as a SolidWorks file. Now you're going to turn your SolidWorks file into the TA, but you also need to save this as a DXF. Now DXF is an exchange format that a lot of our lasers and machines, plasma cutters can use, and it's a AutoCAD type format. So I'm going to use DXF, and I'm going to say save. It's going to use the demo name on here. Again, you're probably going to have your group and your truss number on there. Now, what it's asking for me is don't hit the green arrows and go through this. This is asking me what view to export. Right now, I'm in this kind of view. If I say current, it is going to take a snapshot of this line just like this. What I would want to do is pick front, because front view, if I open this up, was this view on this plane. That's my XY plane. I want to change it to front view. If I was going to leave it current, I would have had to hit spacebar and say normal to, then I could have said current. But probably the best way is just say front view right there and just say accept. And what it's going to do is it's going to show me my frame. So what we can see is the frame here, and I don't see multiple lines. This is looking good. And this is what I'm going to save. And that is now a file that I can take to the machine. And what I'm doing in the background here is I'm opening AutoCAD. You don't need AutoCAD on your machines, but I want to show you what this looks like in a little bit clearer format and how we handle this. This is going to have the geometry that we're going to cut our parts out. One of the things that this is doing is our laser is just going to follow these lines and cut this part out. It can't change the thickness of members, so we can't come in here and lighten out one member, make it thinner. It's just going to be a profile cut. It's going to cut these holes out and then come out here and cut the middle sections out and then cut the outer frame out. Things that we'll end up ditching off for you guys is this stuff right here, the SolidWorks instructional stuff, because we are using an educational version of SolidWorks. It always puts that on there, so we just have to go in there and manually delete it for you guys. But don't worry about doing that. That's something that we'll do on our side, and then we'll import this into CorelDRAW and into the software the machine works with, and we'll cut your parts out. So hopefully that helps you out in understanding how we're going to cut your parts and how you can design them. And I'm anxious to see how well your designs hold up.